We were doing simulations of power electronics, and in the last video we have done buck converter simulation, and in this video we are going to discuss the boost converter in MATLAB Simulink. So first of all, I will bring one DC voltage source. So DC voltage source from the power library, and the input voltage is 25 volt. So this is my input voltage. Now I need one inductor. So for inductor I am bringing series RLC branch. Okay, let's change it to inductor, and the inductance value is 70 microhenry. Now copy this one and paste it for the future use. Okay, we will use it later. After that, this is my inductor. Now I need a switch. So for switch I am bringing MOSFET. I am using the same library, that is power library, and let's make its measurement port uncheck. Okay, now rotate it. Okay, for the measurement of inductor current I will bring one current measurement block. So this is current measurement block and connect it here. Connect this with the drain, and for the pulse I will give pulse generator. Pulse will be given to here. Okay, source will be grounded, so let's ground it here. Okay, now I need one diode. So using the same library, let's uncheck this and connect it here. Now change it to capacitor, and I'm using the capacitance of 300 microfarad. Let's rotate it and connect it here. This is capacitance. Okay. Okay. Now for the measurement of voltage across the capacitor, I will bring 1 voltmeter. Okay, this will be my resistance, load resistance. You can keep it as 10 ohm. Okay, this is R. Now I will bring one display block. This will measure the output voltage, and this is the capacitor voltage. This is the inductor current. Okay, now let's give the values of pulse. I'm using 20 kilohertz frequency, so 1 by 20 kilo, and the pulse width of 40%. So inductance is 70 microhenry, capacitance is 300 microfarad, and the load resistance is 10 ohm. Okay, let's copy this display block and paste it here. This is inductor current. Okay, now I need one scope. I will see pulse, inductor current, capacitor voltage, and the input voltage. For a moment I will see just pulse, input current or inductor current, and the output voltage. So let's make its number of x equal to 4 and make legends on. At the first axis I will get pulse, and in the second I will get inductor current, in the second I will get capacitor voltage, and at the end I will get output voltage. Now bring power GUI. Okay, and run it for the 0.1 second. So you can see for the input voltage of 25 volt I am getting output of 40.48. so we can see the graphs. So this is the pulse and the inductor current. Also you can see the capacitor voltage and the output voltage. So you can see here that for the input voltage of 25 volt and with the duty cycle of 40%, we are getting actually 40.48, and that is expected from the boost converter with the duty cycle of 0.40. You can cross check it by solving it manually, and the formula is Vs divided by 1 minus D. So you can place 25 divided by 1 minus 0.40. Let's solve it in the MATLAB. This is my command window. If my input voltage Vs is equal to 25 volt and duty cycle is D equal to 0.40, then my output voltage is equal to V out is equal to Vs divided by 1 minus 0.40. So this is 41.66 volt. So this is what we are getting actually here, 41 or 40.48. so there is a little bit difference at the output, and that is because we are not using the feedback loop here. So for the closed loop DC to DC boost converter, you will get the exact value of 41 volt at the output.